Hi everyone, welcome to this video where we'll dive into how C code gets compiled into machine code. If you are a beginner in C programming, you are in the right place. By the end of this video, you'll understand the step-by-step process from writing your C source code to running a C program on your computer. Let's see what you will take from this tutorial. Using an ASCII editor, what is ASCII? The relation between ASCII and compilers. What happens during pre-processing? The compilation process overview. So these are the objective we want to achieve in this tutorial. Before compiling a C program, you should write your C source code into a ASCII editor. So you need an ASCII editor to be able to write a C code. This can be a simple ASCII text editor like Notepad. You can use a more specialized code editor like Visual Studio Code or Visual Studio itself. Actually, ASCII is just a way of encoding text into numeric code. After you write the code, the next step is to save the file with this extension .c. For example, your file, after you save it, should look like this one with this extension .c. Here you have an example of C source code. As you can see, all these statements are written in readable human language. Yeah, I'm not gonna get into the syntax of this code because the syntax is the goal of another tutorial. Let's dive in this topic. What is an ASCII editor? First of all, let's see the long name of this ASCII, which it is American Standard Code for Information Interchange. This ASCII is a standard which each character of, for example, of this code, which you can see is written in readable human language, will be converted to a corresponding numeric code. So ASCII is a character encoding system. Yeah. An ASCII editor is just a plain text editor for writing C code. And here you have a few examples. Notepad for Windows, Nano for Linux, Vim for Linux, Gedit for Linux. All these editors allow you to write C code in a C file with this extension .c. Here you have an example how your C source code file should look like with this extension .c. What is the relationship between ASCII and the compiler? So how ASCII and the compiler are related? ASCII, as I said, represents text characters as numbers in a computer. For example, the letter A in ASCII is 65. For example, the letter B in ASCII is 66. That means the C source file is stored in a computer as an ASCII file. Actually, the compiler reads the ASCII file, and the compiler does not read this file. The compiler will not read all these statements from this source, C source code. The compiler will read actually the ASCII file, which is behind the C source code. What exactly the compiler will do will convert the ASCII file into binary machine code in the format of 01. This is the only thing which the processor of the computer understands. These two numbers, 01, and these two numbers are called binary machine code. These two numbers, 01, is organized in a series of 8 01 numbers, like this example. So here we have actually 8 01 numbers, 1, 2, 3, 4, 5, 6, 7, 8. So this series of 01 numbers represents everything what you write in a computer. This is the only thing which the processor of computer is able to understand. For example, if you write this statement, which is a function in C, printf, together with this string in a C program, actually the compiler will not read this statement. The compiler will read the ASCII code which is behind this statement. And what is ASCII code? ASCII code is the corresponding number or number code for each of these characters from this statement, and translates them, actually the ASCII code, into machine code instructions, which are this series of 8 numbers 01. Here you have steps in compilation. We have 5 steps. The first step is pre-processing. The second, compilation itself. The third, it is assembly. The fourth is linking. And the 5 is the execution of executable file, which was made following the compilation process. Each of these steps transform the code into lower level format. Let's start with the first step, which is called pre-processing. Actually, the compiler will process in this stage of pre-processing the preprocessor directives, such as include or define. When you see this symbol hashtag at the beginning of statements or of code lines, that means you have their preprocessor directives. This include directive will insert actually a file, a header file from standard library. This directive define, you can define macros. What actually the pre-processing will do, will remove the comments, replace the macros, and insert the content of header file. What happens during pre-processing? The preprocessor actually runs before the actual compilation starts. It processes only the preprocessor directives, the lines which start with hashtag, not the entire source code. So I repeat, bear in your mind, preprocessing stage of compilation will process only the preprocessor directives, the lines which starts with this hashtag, and not the entire source code. The main tasks of the preprocessor are removing the comments, expanding the include directives, which means inserting the content of header files. Here we have this example of header files, which actually is a file from standard library. The compiler will insert the content of this header file, will expand the macros, the defined macros. Actually, what the processing, pre-processing will do, will replace the macro, in this example pi or p, pre-processing will replace the occurrence of all of this macro pi with a value stored by it, namely 3.14. And also will handle the others directives such as conditional compilation directives. Yeah, you have here a few examples of it. Here you have an example of pre-processing in action. This is a C source code before pre-processing. Yeah, and here you have these two directives, which is include, and another one is the define. Include will insert actually after the pre-processing will be executed, we'll insert the content of this stddo.h content, and everywhere where this macro will appear will be replaced by this value 3.14. Yeah, so here is the code after pre-processing. As you can see, the content of this header file is inserted here, and where this macro appears in our code will be replaced, and where it appears here, yeah, inside the parentheses of printf function. So this will be replaced by this value 3.14, as you can see here. Yeah, so this is the pre-processing, and let's take some key takeaways from this. The preprocessor does not compile the code. It modifies it before compilation. It only processes preprocessor directives such as include, define, not the full program logic. The output of pre-processing is still readable C code, but expanded with actual header files and replaced macros. The file which will be created behind the scene will have this extension I. The second step of the compilation process is the compilation itself. Once the code is pre-processed, the next step is compilation. Actually, the compiler takes over the pre-processed C source code and will convert it into assembly language. This assembly language and this file still readable by humans, but it's close to machine code because the assembly language is a low-level language. So this is the next step, the compilation, when the compiler will convert the pre-processed code into assembly language. The third step is assembly. Actually, the assembly code will be converted in this stage into machine code by an assembler. This assembler actually it is a binary format, and in this format it can be understood by computer because the binary format represents those two numbers 0, 1, which can be understood by processor, but in this stage we can't execute this file because the file which comes out after the assembly, it is an object file, and we can't run this object file, even though the file it is in binary format, which can be understood by computer. Why not? Because there is another step to be done in order to be able to run the C code. The next step is this one, linking. So we have to link this object file with system libraries to create an executable file. Actually, what happens in this stage is that this object file, all the files are combined to make an executable program, an executable file. And the last step is to execute your executable file that you can run directly on your computer. And when you run it, your program display hello world on the screen. Of course, if you use this example, this code, what I showed you here, yeah. So it's this function and this string hello world. Let's see now some popular C compilers, because you need a C compiler to compile the source code of C into machine code. So here are some popular compilers, such as GCC, which can be used or run on Linux, Windows, and Mac OS. Clang, which is a modern C compiler known for speed and efficiency. Microsoft Visual C++ compiler, which comes with Microsoft Visual Studio. TinyCC, which is a lightweight C compiler. Now let's make a summary. Actually, we can summarize all those 5 steps and simplify it into 3 steps. First, you should write the C code using an ASCII editor. After, you need a compiler which will convert the ASCII into machine code. Third step, and the last, the compiled machine code can be run as an executable program, and the outcome of your C code will be displayed in console. So that's all for today. Thanks for watching. If you found this video helpful, please like and subscribe for more tutorials. And if you have any questions or want to see more content like this, leave a comment down below. See you in the next video.